Okay, so we looked at a couple of instances here where one-sided limits would be valuable. The first one that we're going to look at are square roots, specifically square roots that have some sort of restricted domain. So for example, like square root of 4 minus x squared, if we were to graph that, would look like this. And the graph ends as a domain that goes only from -2 to 2. Okay, because when I plug in -2, I get 0. When I plug in 2, I get 0. But when I plug in, for example, -3 or 3, I get the square root of -5, if I were to plug 3 in. Okay? And so as a result of this restricted domain, we can actually only approach -2 from the right, and we can only approach 2 from the left. Okay? In terms of what that means for you guys in terms of solving, is not going to mean a whole lot. So we did kind of two examples. Limit as x approaches -3 from the right of x over the square root of 9 minus x squared. And then example 2, we did limit as x approaches 4 from the left of square root of 16 minus x squared over x plus 4. Okay, so we're still going to be plugging in -3 to see what we get. If we get a number, that's our answer. If we get a number over 0, it does not exist because unbounded. And if we get 0 over 0, we're going to be looking to do some sort of manipulation. Okay, so I'm going to go ahead and walk through this first one, and my recommendation would be for you to pause the video after you watch the first one. Try that second one on your own. See if you've actually understood what the first one was demonstrating. And then when you're ready, restart the video and watch the second one so you can check your answer, hear an explanation if you need it. Okay, so here we go, plugging in -3. We get -3 on top, and on bottom we get the square root of 9 minus -3 squared, which is 9. So this is -3 over 0, which is undefined. So it does not exist because unbounded. Okay, so go ahead and pause the video, give that next one a shot. Okay, plugging in 4, we get the square root of 16 minus 4 squared, which is 16, over 4 plus 4, which is 8, which is 0 over 8. 0 divided by 8 is 0. Okay. So again, the purpose of the one-sided limit is to make sure that we are aware that at the edges of our square root function, we do have an end to our domain, so we can actually only approach from one side. Okay. Second one, absolute values. Now we aren't talking every absolute value, we're talking a very particular absolute value with this one. One in which we have to ask ourselves, are we looking at 1 or are we looking at -1? Now, in Honors Math 3, you would have considered a function somewhat like this one. Okay, absolute value of x minus 2 over x minus 2. And as you discussed the definition of absolute value, you would have at some point talked about the fact that there are two functions within my absolute value, that technically speaking, my absolute value function is a piecewise. Because what does an absolute value do? It makes things positive, right? Meaning, within this absolute value that we have in the numerator up here, we have a portion of our function that was already positive. And when I put these absolute value bars around it, those absolute value bars changed nothing about the function. It was positive, it's still positive. And so if I were dealing with that leg of the piecewise, the positive that stayed positive, if I were to simplify these two values, x minus 2 divided by x minus 2, I'd get 1. Okay? But there's a second part to this absolute value function. There's a portion of this x minus 2 that exists below the x-axis. It's negative. But because we've slapped absolute value bars around it, that portion that's below the x-axis is popped up above the x-axis, which creates that V shape that we know of when we think of our absolute values graphically. And so if we were to deal with the negative leg of this x minus 2 function, if I were to divide these, I'd get -1. And we can see this graphically. If I were to graph this function, you can see we have one portion of our absolute value, not of our absolute value, I'm sorry, of the x minus 2 absolute value over x minus 2. One portion of that is down here at -1, right, the -1. And the other portion is up here at +1. And so here's where one-sided limits come into play, because if I'm approaching this x equals -2 here, I'm sorry, x equals +2 here, from the left, as I'm tracing here and getting closer and closer to x equals 2, my y values on all of that function are -1, meaning I'm approaching -1. If I'm approaching +2 from the right, as I get closer and closer and closer to 2, my y values there are +1. And so my limit would be +1. Depending on which side I am approaching from, I get a different value. And so we have to ask ourselves that question. Well, which one am I looking at? Okay, for this one, we're going to do 3. So let's do limit as x approaches -2 from the left of 3 times the absolute value of x plus 2 all over x plus 2. Okay, so I'm going to walk through this one. If we plugged in -2 here, we'd get 0 over 0, which is our cue that we're going to do something else. In this case, we're looking at our x plus 2's going, wow, man, it would be really nice to be able to simplify those. And the reality is that we can. We just have to figure out, when I simplify them, am I 1 or am I -1? Because remember, this is a piecewise function up here, this absolute value. Unfortunately, plugging in -2 is not going to help me a whole lot, because plugging into -2 gave me 0 over 0. But remember that graph that we were just looking at. The nice thing about our absolute values is, as I look on either side, every number, every x value plugged in generated the same y value. What does that mean for us here? It means that this 3, which is a coefficient, can hang out, and then I can use any number I want, as long as it is, in this case, left of -2, to help me test. Again, I'm not actually plugging in a number lower. What I'm plugging in is -2. But I'm using a number left of 2 to help me test whether I'm 1 or -1. And so think of a number left of -2, -3, -4, -5, -2.1, right? Any number left will work because we're just testing. We aren't actually plugging in, we're just testing to see am I positive or negative. Because I know I'm 1. I just have to figure out the sign. And so I'm going to go ahead and plug in -4. So I'm going to ignore this 3 for a bit, because again, it's hanging out, it's my coefficient. If I were to plug a -4 into the top, would I have a positive or a negative number? I would have a positive, right? Anything absolute valued is positive. Divided by, if I plug -4 in down here, what would I have, positive or negative? I'd have a negative. So a positive divided by a negative is a negative. That tells me that for this function, because I'm approaching -2 from the left for this function, that this is going to be -1, because a positive divided by a negative is a negative. And again, I use -4, but you could have used -3. Absolute value of -3, positive divided by -3 plus 2 is negative. Positive divided by a negative is a negative. If you plug in -10, you'll still get a negative. It's helping you test which one of these is at play. And so my answer is -3. Okay. Example 2. Limit as x approaches 5 from the right of 5 times the absolute value of 5 minus x all over 10 minus 2x. Okay, so if you feel like you understood that first example and you want to go ahead and pause the video and give the second one a shot, you're more than welcome to do so. Otherwise, I'm going to walk through the second one as well, and then there will be a third one. You can pause the video on that one. Okay, so example 2 here. Plugging in 5, we get 0 on top divided by 0 on bottom. So I'm going to be looking for what else I can do. I notice I have a 2 I can factor out. So let's go ahead and do that. We have 5 times the absolute value of 5 minus x. 2, 5 minus x. And then we see our simplification point. 5 minus x over 5 minus x is 1. The question is, are we positive 1 or are we negative 1? Because we have an absolute value, and an absolute value is a piecewise function. Okay? So we're going to test. This 5 is going to hang out because it's a coefficient anyway. And now I'm going to be plugging into my function to figure out if I'm positive or negative something right of 5. So go ahead and think to yourself, what's right of 5? And any number will do. So maybe 6, 7, 8, 9, 10, doesn't matter. Let's plug in 10. Okay, so ignoring the 5 halves, if I plugged in 10 on top, would we have a positive or a negative? We'd have a positive. If I plugged in 10 on bottom, would we have a positive or negative? We'd have a negative. A positive divided by a negative is negative. And so this is negative 1. If we had gotten positive, it would have been positive 1. Again, we know it's 1. It's the sign that we're having to answer, or having to figure out for ourselves. Okay, and then example 3. This one, if you have not already, I would recommend making this one that you pause and try on your own so that you can figure out kind of, am I understanding it, or am I going to come into class tomorrow and ask some questions? But I would recommend pausing this one, give it a shot on your own, restart the video when you are ready. Okay, and so here we go. When I plug in negative 3, I get 0 over 0, which is not a viable answer, so I'm going to go ahead and factor. Limit as x approaches negative 3 from the right. Absolute value of x plus 3, and down here we have 4 times the quantity of x plus 3. Okay, so this is going to be either 1 or negative 1, so I'm going to let the 1/4 hang out. And I'm going to use a number right of negative 3. So think of a number right of negative 3. 0. 0 is right of negative 3. Okay, so using that to help me test, am I positive or negative 1? If I plug in 0 on top, do I get a positive or a negative? I get a positive. How about on bottom? I get a positive. A positive divided by a positive is a positive. And so this is positive 1. Okay. Okay, the last one that we just barely started doing, which we're going to practice some more tomorrow for sure, are these piecewise functions. Okay. So, piecewise functions, example 1, and again we're going to do 3. F of x equals negative x plus 1 over x squared minus 2. Not over, I'm sorry, negative x plus 1 when x is greater than or equal to negative 2. X squared minus 2 when x is less than negative 2. There we go. Okay, so where one-sided limits come into play with piecewise functions is this fact. I could ask you for the limit as x approaches negative 2 of f of x. I also could ask you for the limit as x approaches negative 2 from the left or from the right, but in this case I'm asking you for a two-sided limit. Okay, well picture for a moment here with me graphically, when we are looking at a two-sided limit, what are you doing as you solve it? Not what are you looking for, what are you doing? Okay, and I'm hoping as we're picturing that two-sided limit that you're picturing somehow, either with your eyes or with your fingers or something, tracing a function from both sides. Right? This is a two-sided limit. And then did we care about what happened at x equals negative 2? Was the point important? And Again, I'm hoping we're all recognizing that no, it's not. From day one, the very first graphic limit that I had you do last Tuesday, on that picture, if you go back and look in your 1.2 notes, the very first limit we did was a piecewise function where the graph came together, but at -6, my point was located above the graph. And we talked about from that first one that the limit had everything to do with the approach and nothing to do with where the point was actually located. Okay, so why am I highlighting all of these? Because when we are evaluating a piecewise function, if I'm asking you to find the limit as x approaches -2, look at where -2 is on this piecewise function. It's a breaking point. To approach from both sides of -2, I need to look at what's happening for the less than, and what's happening from the right, or from more than, right? I have to consider them both. And so think for yourself, okay, if I have to consider them both, -2 from the left and -2 from the right, what would be values left of -2? -3, -4, -5. Well, where do we see that -3, -4, -5 at? You see them right here, right? Less than -2. So for my -2 from the left, I'm concerned with this bottom function. What happens as we approach -2 from the left? Well, -2 squared is 4, minus 2 is 2. And then what happens as we approach -2 from the right? We'll think about values that are right of -2. -1, 0, 1, 2, 3. Where are those? That's this top function, right? -x plus 1, -x plus 1, which is 2 plus 1, or 3. Notice that as I considered my limit from the left and my limit from the right, I never once asked, where do I equal -2? Right? That has no impact on my limit. Think graphically. What happens at x equals -2? What's on your graph when x equals -2? That's a point. So this equals here has nothing to do with my limit. This equals here is my point. Okay, finishing out the problem. Since I'm approaching -2 from the left, and that's 2, and then approaching -2 from the right, and that's 3, okay, picture that graph coming in at 2, coming in at 3. What's my two-sided limit? It would be does not exist because does not agree. And this is why we need one-sided limits. It helps us with figuring out our two-sided ones at a break in a piecewise. Okay, 2 does not equal 3. Okay, example 2. If you feel like you understood what was going on based off that one example problem, then maybe pause the video, give the second one a shot on your own, restart it when you're ready, or if you'd like to kind of hear one more before doing one on your own, feel free to keep watching. Example 2, we have f of x equals 1/2 x plus 1 when x is less than or equal to 2, and 3 minus x when x is greater than 2. And I'm going to ask you, what is the limit as x approaches 2 from the left? Okay, so again, pause the video if you're going to do so, otherwise I'm going to walk through this one. Okay, I'm not asking you for a two-sided limit on this one. I'm just asking you for a one-sided limit, 2 from the left. Okay, I am not plugging into equals. I will never plug into equals for a limit. Equals is a point. A limit is about the approach, right? As we trace the graph, what does it look like our y value should be? So 2 from the left, think about what numbers are left of 2. 1, 0, -1, -2. Where are those? Okay, those are with this top function. So I'm going to go ahead and plug in there. 1/2 times 2 plus 1. 1/2 times 2 is 1, plus 1 is 2, and so my limit is 2. But again, not because we are equals, but because the less than is pointing me to my values left of 2. Okay, let's go ahead and do one more, and then we're going to pick up with this when you guys come into class tomorrow. We'll practice these as well as touch base on the other two you've seen in this video to make sure if there are any questions we've gotten them answered. Okay, we have f of x equals x squared minus 5 when x is greater than 3, 4x plus 1 when x equals 3, and 2 to the x minus 4 when x is less than 3. And I'm going to ask you for the limit as x approaches 3 of f of x. Okay? You're going to go ahead and pause this video, give this one a shot, and then restart it when you are ready. Okay? So, to find the limit from both sides, because that is a break in my piecewise, I do need to individually consider what is happening from the left and what is happening from the right. Again, the limit has nothing to do with the point. It's very tempting in this case to say that the limit as x approaches 3 of f of x is 13. It's very tempting to want to say that, because if I plugged 3 into where x equals 3, I'd get 13. But that is not a limit. This is the point. I want to know what the limit is. And so as I approach 3 from the left, think about numbers that are left of 3. 2, 1, 0, -1, -2. Which one of these equations pertains to those values? 2, 1, 0, -1, and -2. Well, that's this guy down here, right? 2 is less than 3, etc. So I'm plugging in here 2 cubed minus 4. 2 cubed is 8. Minus 4 is 4. Okay. 3 from the right. Where am I plugging in there? Think of numbers right of 3. 4, 5, 6, 7, 8. Which one of these equations does it pertain to? Right up here. 4, 5, 6, 7, and 8 are all greater than 3, so I'm plugging in here. 3 squared minus 5 is 9 minus 5, or 4. Okay, and so then if I'm approaching from the left and I'm 4, and I'm approaching from the right and I am 4, what does that mean my two-sided limit is? 4. They agree. And so that is my answer.